Hey guys, welcome to our final lesson on factoring. Today we're going to talk about solving polynomial equations by factoring. And this is going to be a little bit different than what we've done throughout the rest of the year with solving linear equations, because we're no longer solving linear equations. In this case, we're going to be looking mainly at solving equations that involve x squared or a quadratic. You'll spend a lot of time dealing with this next year in Algebra 2 again, but we're going to introduce the idea here in factoring because the way that we solve these equations goes along with what we've been talking about the past couple weeks. Before we get into solving though, the first thing we want to talk about is this thing called the zero product property, and you can see it here in the middle of the screen. And it says if a times b equals 0, meaning if I have two factors and I multiply them and I end up with 0, what we know is that either a is equal to 0, b is equal to 0, or maybe they're both equal to 0. And really all we're saying is that when you multiply two numbers and you get 0, one of them has to be 0. This might not seem like it's really that important, but it honestly sets up everything that we're going to do moving forward in this lesson and everything that you're going to do moving forward next year in Algebra 2. So we're going to talk about the zero product property and see how it works with solving polynomial equations. Let's look at our first example. So in this equation, we have x squared minus 3x minus 18 equals 0. I want to solve this equation for x. The problem is I can't follow the same rules that I normally would for linear equations, because even if I try to move, let's say, this x over to the right, I'm still going to have an x squared term over here on the left. So the fact that I have both x and x squared, that causes a problem in this case. Instead, what we want to think about is our zero product property, right? We're going to think about the fact that if a times b equals 0, that means a equals 0 or b equals 0. And the reason we're going to think about that is because in this case, the x squared minus 3x minus 18, if I think about what I just talked about in factoring a couple lessons ago, this is a quadratic trinomial. What method can we use to factor that expression? If you said reverse FOIL, you're correct. We can actually take this expression and actually simplify it a little bit. We split the x squared into x and x. I look at my sign, which is negative here, which tells me I'm going to use 1 plus and 1 minus. And then I want my factors of 18 that add up to negative 3. So 18, I could have 1 and 18. I could have 2 and 9, or I could have 3 and 6. There's the pair that's going to work. I want to use the 3 and the 6. Specifically, I want the 6 to be negative. I want the 3 to be positive. And here's the thing. Now my equation says that x plus 3 times x minus 6 equals 0. Well, that means either x plus 3 equals 0 or x minus 6 equals 0. But if I go a step further, if I know x plus 3 equals 0, if I subtract the 3 over, I can actually solve and see x equals negative 3. Or if I add the 6 over in the other equation, that tells me x equals 6. So I get two solutions here, either x equals negative 3 or x equals 6. And if I were to take these and plug them back into this original equation, I would see that my answer becomes 0. So if I took negative 3 squared minus 3 times negative 3 minus 18, this would become 9 plus 9 minus 18. 18 minus 18, that's 0. That's what it should have worked out to be. So I know the negative 3 works. And if I tried the 6, if I take 6 squared minus 3 times 6 minus 18, again, I'm going to get 36 minus 18 minus 18. 36 minus 18 is 18. 18 minus 18 is 0. So both of these checks show that negative 3 and 6 are my solutions. And that's how we're going to go about solving these equations that have an x squared term. We're going to use the zero product property, and we're going to use our factoring skills to help us. Let's lay out the actual process here on the next slide. Alright, so unlike linear equations, which basically follow the same basic process each time, getting the variable on one side, constants on the other, using inverse operations, polynomial equations actually have a 5-step process for solving. The first step is that we want to make sure that we get a 0 on one side of the equation. In other words, I'm going to put everything on the same side. So in our last example there, we saw the x squared, the x, the constant term. They were all on the left-hand side, and I had 0 on the right. Once I've done that, and I've gotten everything on the same side, step 2 is to factor the remaining polynomial completely. And this is important right here. The fact that it says factor completely. Because this tells me I'm going to use any possible method. So I might have to reverse FOIL. I might have to use GCF. I might have to use perfect square trinomials or difference of squares. Maybe I have to use multiples. But I know that I'm going to be having to factor completely. Then step 3, once we've factored completely, which in the first example we reverse FOILed, then what we did was we set each variable factor separately equal to 0, meaning we used that zero product property. I knew those two quantities multiplied to give me 0. The only way that happens is if one or both of them are equal to 0. So we do that. Once we set the quantity equal to 0, step 4 is you're going to solve each resulting equation for the variable, meaning you're going to solve a linear equation. So you're going to either add or subtract and maybe multiply or divide. And then step 5, once we've done that, we want to check and make sure that each solution works in the original equation. So that would be the last thing I did on the last slide. I plugged the -3 in, I plugged the 6 in to show when I plug those into the equation, I do indeed get 0. So we're going to follow this 5-step process for our polynomial equations, and we're going to work through some examples together, and you're going to try some on your own today. Let's move on to our second example. Alright, so let's take a look at example 2. Example 2 says d squared plus 5d minus 24 equals 0. So I'm going to follow that 5-step process. Step 1, I want to make sure that everything's on the same side. If I take a look, that's already set up, so we're good. Step 2, I want to factor the expression that's on the left here. And because I have 3 terms and the largest one is a square, this tells me I'm going to reverse FOIL in this case. So I'm going to set up my 2 binomials. And I'm going to try and reverse FOIL. So the d squared splits into d times d. I look at my signs. Since the last term is negative, that means we use one positive, one negative, so different signs. And then I need factors of 24 that add up to 5. So let's see, 24, I could have 1 and 24, I could have 2 and 12, I could have 3 and 8, I could have 4 and 6. And if I check, I'm pretty sure the ones I want to go with are the 3 and the 8. Because if I took a positive 8 minus 3, my outside would be negative 3d, inside would be positive 8d. They add up to the positive 5d. So there's my reverse FOIL. We're all good. So d plus 8 times d minus 3 equals 0. Again, the only way that works is if the first quantity equals 0 or if the second quantity equals 0. And now that we have these set up, d plus 8 equals 0. If I solve for d, that tells me d equals negative 8. Or if I have d minus 3 equals 0, I would add the 3 over. D equals positive 3. There's my 2 solutions. And again, if I wanted to do the check, my check would be to plug in negative 8. So if I took negative 8 squared plus 5 times negative 8 minus 24, that would be 64 minus 40 minus 24. 64 minus 40 is 24. 24 minus 24 is 0. That one works. I can do the same thing with the 3. So if I took 3 squared plus 5 times 3 minus 24, 3 squared would be 9. 5 times 3 would be 15. 9 plus 15 would be 24 minus 24. That would be 0. It works. So there's our two solutions. -8, +3. We did our check. That's it. Let's move on. Here in example 3, we have the equation y squared minus 49 equals 0. And we go through that 5-step process. First, y squared minus 49, they're on the same side, 0's on the other side. That's good. Step 2 is I have to factor completely. In this case, this is where it's important for you to be able to identify what method of factoring should I use when. And here, if you're looking at it, you're probably saying, wait a second, y squared minus 49, y squared is y times y, and 49 is 7 times 7. There's only two terms. They're both perfect squares. They're being subtracted. That means this is a difference of squares. So you're not always going to reverse FOIL. You might actually use the other methods that we talked about. So difference of squares splits up into two binomials as well, where we're going to have the same terms. The y's are the first terms, the 7's are the second terms. But in the first one, we would have y plus 7, second one, y minus 7. There it is. It's all factored. So now we set each of these equal to 0. So y plus 7 equals 0, or y minus 7 equals 0. First equation, I would subtract the 7. I get y equals -7. Or, in the second one, I would add the 7. I get y equals +7. There's my two solutions. And I'm just going to do my check mentally in this case, because I would be plugging in -7 or 7 in for the y. So if I took -7 squared or 7 squared, they both would give me 49. 49 minus 49 is definitely 0. There's our answer. Let's move on to the next example. Alright, so example 4, we have 9k squared plus 3k equals 0. Going through that checklist, step 1, everything's on the same side. We're good. Step 2, we need to figure out how we're going to factor this. So take a look, think for a second, pause, and then see if you have the correct factoring method. Because we have just k squared and k in this case, there's a GCF between those two terms, and the coefficients are 9 and 3. This one's going to be factored using a GCF. We're not going to reverse FOIL because there's only two terms. I can't use a difference of squares because 3k isn't a perfect square and it's a plus, not a minus. So we use the GCF. So if I look at those two terms, the GCF for them would be 3k. And then the leftover expression in this case, if I factored 3k out of 9k squared, that would leave me with 3k. But if I factored 3k out of itself, I have to have something in this place. It would be 1, because 3k times 1 would get me back to 3k. So now I've factored, and in this case, I don't have two binomials being multiplied. Instead, I have the variable factor 3k multiplying 3k plus 1. So I have to set each variable factor equal to 0. So either 3k equals 0 or 3k plus 1 equals 0. And in this case now, 3 times k equals 0. Well, if I divide by 3, that means k equals 0. Over here, I need to do a little bit more work. I would first subtract the 1 because this is a two-step equation. And then I would divide by 3. So I get k equals -1/3. So my two solutions in this case, k equals 0 or k equals -1/3. And again, if I were to take the time to plug those back in and check, I would find that both 0 and -1/3 work in this case. Let's move on to the next example. Alright, so in example 5 here, we have w squared plus 8w equals 9. And you may notice something different right off the bat about this problem versus the others. Remember our 5-step process for solving here? The first step says we need to get everything on the same side. When I look at this, notice w squared and 8w are together, the 9 is not. So the very first thing we're going to do is we're going to subtract the 9 over. That way we now have w squared plus 8w minus 9 equals 0. At that point, now I have everything on the same side. Now I'm going to factor. So go ahead and pause. Try this one on your own. So now that you've got everything on the same side, you factored it. You should have reverse foiled. Even though I see perfect squares, the 8W does not work if I try and split it up the same way. So instead I reverse foiled it with W's, 1 plus and 1 minus. And in this case, we're going to use a positive 9 and a negative 1. So if those are multiplying to give me 0, that means either W plus 9 equals 0 or W minus 1 equals 0. When we solve, we subtract the 9 on the left here. We add the 1 on the right. We get two solutions. We get either W equals negative 9 or W equals 1. And if I were to plug those in, I would find that they work for both of those values. One of the things that you've probably noticed that's a little bit different about polynomial equations is we don't end up with just a single answer. We're ending up with two answers. And again, that's because I'm saying that two quantities multiply to give me 0. The only way that works is if either the first one or the second one or both of them are 0. So there is going to be cases where maybe we only get one number because it ends up being the same. But in most cases, we're going to end up with two values that would be solutions to these types of equations. That's a big difference from linear equations. We got one more example to work through, and then we'll talk about what your assignment is for this week. All right, here's our final example. 2n squared minus 2n minus 16 equals 164. Working through the process. If you want to try this on your own, go ahead and pause and rejoin when you're ready. First thing I need to do is get everything on the same side. Since the 2n squared, the negative 2n, and the negative 16 are already on the left, it makes sense to bring the negative 1 or bring over 164 by subtracting it. So now we're going to have 2n squared minus 2n minus 180 equals 0. And at this point, I'm noticing 2, 180. They're all even. That means that they're all divisible by 2. So I can't factor out an n, but I could technically divide all those things by 2 to reduce them. What allows me to do that is I can also divide the right-hand side by 2. And that way, we'll now get those to cancel out. So instead of having to reverse foil 2n squared minus 2n minus 180, we're going to end up with n squared minus n minus 90 equals 0. So go ahead, take a minute, try and reverse foil that. When you were reverse foiling, you probably said, I want to split it up into n and n. The last term's negative, so I'm going to use 1 plus and 1 minus. And in this case, I need factors of 90 that add up to negative 1. So if I think about it, 9 and 10, I'm going to use a positive 9 but a negative 10. So that way they add up to negative 1. And then I have to set these equal to 0. So we'd say n plus 9. I'm going to subtract the 9. So I get n equals negative 9. Or n minus 10 equals 0. I'm going to add the 10. So n could equal 10. There's my two solutions. If I were to plug those in all the way back in the original equation, I should find that both negative 9 and 10 work. This week, you're going to have some IXL problems. You'll have a graded assignment to submit. We'll have our weekly Zoom meeting on Wednesdays. And if you have questions throughout the week, send me a message, an email. I'll help you in any way I can. I hope you guys are all doing well. Thanks for watching, and take care.